So, today we are going to read science. In science, we will read about the physics. So, let's start. And this will be according to the NCERT CBSE. So, let's start it. So, I am ARYAN and going to discuss about the physics of class 9. So, let's start it. So, our first chapter in our book of physics is chapter 8, and the name of chapter is motion. So, first of all, we have a question that what is motion? So, it has a very simple answer. A body is said to be in motion when its position changes with respect to a reference point. Means, it says that a body who changes its position with respect to a reference point, not with any not means we have read in previous classes that it changes with the time, but in class 9 we have to read about the reference point. So let us understand what is reference point. So for learning reference point, we will learn it after some time. Then after you will understand more quickly that what is reference point. So let us comes in our next topic. Our next topic is rest. So a body is said to be in rest when its position do not changes with respect to an reference point. Means a body who does not change its position with the respect of reference point is known as rest. Okay, so if a body is not changing its position, means if a body like we can see the pencil put on a table, so it is not changing its position. That's why that pencil will be that pencil is in the rest position. Okay, so let's see our next topic. So now we have to learn how we can describe a location of an object. Means sometimes we say like means how can we describe, how can we indicate a location of an object? Means that object is on that place, so how can we describe it? Okay, so let's see this answer, that we can describe the location of an object by specifying a reference point. Now we have to learn about reference point. So how we can do it? So we can do it by specifying the reference point of that object. Okay, of that object. So let us understand this more by an example. So let us assume a school. Okay, a school in village is 2 kilometers north from railway station. 2 kilometers north means north, 2 kilometers in north side from the railway station. Where? From the railway station. So we have specified the position of the school with the respect of railway station. Okay, so in the example, the railway station is reference point. Means because we are specifying the location of the school by specifying the railway station. Means 2 kilometers north from railway station. From where? So from railway station. So here railway station is our reference point. So specifying any place. Okay, specifying any place with another thing. So that another thing will be as the reference point. So in this example, railway station is reference point. Okay, so we could also choose other reference point to our convenience. Okay, we can choose another, like we can choose some other places which is near by the object, by which we can specify the location of that object. Therefore to describe the position of an object, we need to specify the reference point also, and that reference point is also known as origin. Okay, so let's go to our next topic. So here we can understand reference point more deeply. Okay, so you can see there is a graph, so there is a number line, you can also say it as a graph. So you can see Coma's house at 0. Okay, at 0 Cosma house. So Cosma's house is reference point. Okay, so now 300 meters right hand side of Cosma's house there is a shop, and 300 meter left hand side of Cosma's house there is a school. So we can put Cosma's house as a reference point. So we can say where is shop, so we can say 3 kilometer right from the Cosma's house. Where is school, so 3 kilometers left from Cosma's house. So we can see that Cosma's house is a reference point. In here right side of her house, after 300 meter there is a shop, and in her left hand side there is a school. So we can describe where the Cosma's is standing with specifying the reference point. Means if Cosma's is, suppose another example we are taking, if Cosma is standing on a road, so how can we specify where is Cosma? So we can specify with taking another reference point. Okay, like if she is 200 meter left from her house, we can say standing 100 meter from the shop. Okay, means 200 meter from the house, so the total distance is 300 meter, and he is standing at 200 meter from his house, so he is 100 meter from the shop. So how we can specify the reference point of an object. So let us go through our next topic. So our next topic is physical quantities. So what is physical quantity? So it is a property of a material that can be measured. Means a property of a material which is measurable. There are some properties of material which are not measurable, but all the property of the object which can be measured or measurable, which are measurable, are known as physical quantities. So there are two types of physical quantities. You can see in the right hand side, I have located it: scalar and vector. Scalar quantities and vector quantities. So let us understand this. So what is scalar quantity? So it is a physical quantity having only magnitude, not direction. Okay, not direction. So what is magnitude? Numerical values are known as magnitude. Means 8 kilometer. So here 8 is your magnitude, but not kilometer. Only 8 is your magnitude, means numerical values. So not only numerical values, not direction. We have seen a 2 kilometer north. So here 2 kilometer north cannot be a scalar quantity, because we have written that not direction, and north is a direction, right, left, these are the direction. So it is every quantity which has direction, it could not be a scalar quantity. So there are some examples I have seen, like time, mass and temperature. See, I am not saying about the weight, I am saying about the mass. There is a huge difference between mass and weight. We will learn it in our next chapter, which is gravitation. Okay, so let's understand vector quantity. So what is vector quantity? It is a physical quantity having both magnitude and direction. Okay, and weight is an example of vector quantity. Here it has both, means 2 kilometer north. We can say north because it has both magnitude, means numerical values, and direction also. Directions right, left, north, south, east, west. Okay. means both thing it is having. In scalar quantity we have seen only one thing which is magnitude, but here it has two things. It has both two things, magnitude and direction. So let us understand the let us go through our next topic. So our next topic is distance and displacement. So what is it? We have learned distance, but displacement is a new topic for us. So let us understand the displacement and distance. What is the difference? Okay, because most of students confuse between this. So distance is the actual path length traveled by an object. Means if a object is traveling a path, so whatever the path he has traveled, whatever the path he has traveled, so that path's length means if he travel 2 kilometers, so 2 kilometer will be its distance, and it is a scalar quantity. We have learned scalar quantity means it has only magnitude, and its value is always in positive. Means this distance cannot be in negative and 0. Its value will be always in positive. Okay, understood? Then next, displacement. So see, the shortest distance, displacement is the shortest distance between initial position and final position. So what is initial and final? Initial means a starting position, where you are starting to travel. Where is your starting point, starting position? That position is known as initial position. And final position, where you ends your journey, where you ends your any work. Okay, so that is final. So initial position and final position. So not here in distance we can see the whole path, but in here we only measures the distance between initial and final. Okay, it is a vector quantity, and its value can be, okay, its value can be in positive, negative and 0 also. Means it can be in positive also, 0 also, and negative also. And both SI unit are same, meter. So now you can see an picture and diagram in which I have shown like A and B. Your A is your initial position and B is your final position. Means A you are starting to travel and B you ends your traveling. So you can see the distance which is made up with blue dotted lines, and I have specified also it. So all the blue dotted lines, we walking on that line, but from where we have started and from where we have ended, I have so between that distance I have specified that with the red line. So that red line, that distance which I have specified with red line, that will known as displacement, but the blue dotted lines were distance. So with the help of this figure you can understand the difference between distance and displacement. So let us move to our next topic. Our next topic is speed. So we are learning speed from class 6. The distance per unit time is called speed. Okay, it is a scalar quantity, means it has only magnitude. Its value is always in positive, it can't be in negative, and its SI unit is meter per second. Okay, and we know this value, we know the formula of speed, which is distance by time. Okay, the formula of speed is distance by time, and distance per unit time is known as speed. Its value is always in positive, and it is a scalar quantity. Now velocity, it looks like a very big topic or very hard topic, but it is most easiest thing you can understand. So the distance per unit time in a given direction is called velocity, or you can also say it is the speed with direction. Means see, you know speed and you are adding direction with speed. Only this much. Means like 200 meter per second north. 200 kilometer per second north. So 200 kilometer per second is your speed, but if you add north, so it will become your velocity. It is a vector quantity, because we have read that vector quantity has both magnitude and direction, and here we have also seen in the definition, it is speed with direction, or it is distance unit, it is the distance per unit time in a given direction. Okay, and its value can be in positive, negative and 0 also. Remember one thing, all the vector quantities can be in 0, negative, positive. Okay, all the vector quantities can be in positive, negative and 0 also. Okay, so let us understand our next topic. So its SI unit is also meter per second. Velocity, speed in a given direction, we have seen, like if a car is moving, so here it is in a speed with a given direction. So there are two very important formula I have given, that average speed and average velocity. So the formula of average speed is this total distance by total time, and the formula of average velocity is initial velocity plus final velocity by 2. So see, average velocity means initial velocity, means the velocity which is in your initial point, and the velocity in your final point. If the sum of these and divided by 2 are, then the value become of your average velocity. Now we have to learn about uniform motion. So when a body travel equal distance in equal interval of time, then the body is in uniform motion. Means suppose if a body is traveling in a path, then in 100 kilometer, in every 100 meter, in every 1 hour it is completing the 100 meter. In another 1 hour it is completing 200 meter. Another 1 hour it is completing 300. Another 1 hour 400. Means in equal interval of time it is covering the equal distance. So this phenomenon is known as uniform motion. Means the motion is in uniform way. It is not changing or increasing or decreasing. Its speed is constant, and we used to show the uniform motion in the graph like this. I have given in the figure. You can see. By this we can see, we can express the uniform motion in the graph. So let us understand non-uniform motion, means the opposite of uniform motion. So non-uniform motion, it is just opposite. Means when a body travels unequal distance in equal interval of time, then the body is in non-uniform motion. Means means unequal distance in equal interval. Okay, not you could not say that equal distance in unequal interval of time. You have to say unequal distance in equal interval of time. Means in first 1 hour the car is completed 200 kilometer, in second it is completing 50 kilometer. So here it means the motion is not in the uniform way, it is non-uniform way. The speed is increasing, the velocity is increasing, and suddenly it is decreasing. So this by this we can know it is a non-uniform motion. The motion is not in a uniform way. Means in same interval of time it is not completing the same distance or equal distance. It is completing unequal distance, and we shows the non-uniform motion in graph like this. I have given the picture. It can be any zigzag line, and U shape, V shape, any type of line, but not straight line. If you make straight line, so it will become your uniform motion. So this much we have to learn today, and we have to discuss today. In my next video I will discuss the another topic and other part of this chapter. And thank you.